Let's look at how to solve this question now. First, we begin with the balanced equation. And here you see that the mole ratio of calcium carbonate to hydrochloric acid is 1 to 2, with the products being calcium chloride and carbon dioxide. Now the first thing is we should convert the 1.05 grams used in the investigation into moles. And here is how we do that. We divide this mass in grams by the molar mass. And when we do that, this is how we would lay out the calculation. And the 2 grams units will cancel, leaving you with this number of moles. So this is the amount in moles of calcium carbonate that was available for this reaction. If this were the amount of calcium carbonate that was available, and the mole ratio is 1 to 2, then it means for a complete reaction to happen that we need this many moles, twice as much as the calcium carbonate. We need this many moles of hydrochloric acid, and we'll get this many moles of calcium chloride and this many moles of carbon dioxide. But how many moles of hydrochloric acid did we actually have? And that can be determined using this equation, N equals CV. But we must convert the 10 milliliters given in the question into dm cube. And this is how we do that. We divide by 1,000. Dividing 10 by 1,000, we get 0.01 dm cube. And the concentration of the hydrochloric acid, 0.1 moles per dm cube. Multiplying these two, it comes to 0.001 moles. And that is the number of moles of hydrochloric acid that was available for this reaction. So with that small amount of hydrochloric acid available, and it being a lot less than the amount needed to completely react with the 0.015 moles of calcium carbonate, it means that given the ratio of 1 to 2, that if you had this many moles of hydrochloric acid, then only half of that number of moles of carbonate would react with it. And you'd get this number of moles of calcium chloride and this number of moles of carbon dioxide, in keeping with the mole ratio of 1 to 1, 1. You don't have enough hydrochloric acid in the mixture to react with all of the calcium carbonate. In other words, hydrochloric acid is what's limiting you from having a reaction of all of this calcium carbonate. This is the chemical that is in excess, and this is the one that's limiting. Now, to determine the mass of carbon dioxide produced, we need to convert moles into mass, and this is how you would do that. You multiply the moles by the molar mass of carbon dioxide, which is 44 grams per mole. And if you wanted to know how much volume of carbon dioxide that would be at standard temperature and pressure, or SATP, where 1 mole of a gas occupies 24 liters or 24 dm cube, then you take the actual number of moles you have and you multiply that by 24. And it comes to 0.012 liters, which is equal to 12 milliliters of carbon dioxide.